Hello everyone and welcome back to another video. In this video we are going to discuss about uniform distribution. So this is a series in which we will discuss about all of the discrete distributions that we have. Starting up we have uniform distribution. So uniform distribution, let us first see what examples uniform distribution has. So uniform distance so in uniform distribution, basically what we have is that the probability of each outcome, okay? So the probability of each event is a constant, right? And it is defined by the function 1 by n. So if we look at the example of rolling a die, then the probability of getting a 1 is 1 by 6. Probability of getting a 2 is also 1 by 6. Similarly, probability of getting a 6 is also 1 by 6. Hence, we say that this is a uniform distribution. Similarly, if we talk about selecting a card from a deck of cards, from a deck of 52 cards, then the probability of, let's say, getting a king of king of spade, right? So in that case, the probability will be 1 by 52, right? So this is how we define uniform distribution, okay? And definitely this is a discrete uniform distribution because our outcomes are countable and they are discrete. There is no continuous thing going on. We cannot have our values in decimal. We cannot have a dice and say that we have 1.1. What is the probability of getting 1.1? That is not possible. We will only have integer numbers when we roll a die, which will be 1, 2, 3, 4, 5 and 6. Okay. Now moving ahead, this is how we define the PMF, or the probability mass function of a uniform distribution, which is simply 1 by n, right? Now n can take value from 1, 2, 3 and so on till n. Any value can n have depending upon how many numbers we have in our hand, okay? Now we will derive the expectation of x, or we call it mean, okay? So it will be nothing but summation of xi, this is x, summation of xi. We have already covered the topic of expectation, how we calculate expectation. So that is x into f of x. So here our f of x is nothing but 1 upon n, right? Now if I take 1 upon n out of the summation, then we know that summation of xi, where I goes from 1 to n, okay, it will be n into n plus 1 by 2. This is a normal arithmetic progression, as we may call it. So in that case we will get the value as n into n plus 1 by 2 into 1 upon n, which we already have, which is our f of x. Hence on solving n and n get cancelled out and we get n plus 1 by 2 as our expectation of x. Moving forward, we will now calculate the variance of x, okay? So variance of x is nothing but expectation of x square minus expectation of x whole square, okay? So now expectation of x we have already calculated, which is this n plus 1 by 2, right? We will simply whole square that value over here, right? And also summation of xi square into 1 upon n. So if we take 1 upon n outside, summation of xi square is nothing but n into n plus 1 into 2n plus 1 by 6, okay? So n and n get cancelled out and we finally have this value. When I multiply these two and we try to take the LCM, we finally have this as the value. You can do the calculations yourself and check it, okay? So this is what we get as variance of x. Now it is very important to understand how important these distributions are and what sort of answers we can get once we know that this is the distribution that this particular event or this particular experiment will follow, right? For example, rolling of die, picking up a card from a deck. So if we know that, okay, this follows uniform distribution, we can calculate so many things and we will see how, okay? So here we have a case where we have 10 ping pong balls which are numbered from 1 to 10 and they are placed in a bag. Now one ping ball is removed from the bag randomly. So basically it's nothing but you have 10 balls and you are picking up one ball out of that bag. So we certainly know that probability of selecting 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay? These are the balls. So first ball, second, third and like that till 10th. So any ball picking up, the probability of picking up any ball is 1 by 10. Each case 1 by 10. Right? So this is nothing but what? Uniform distribution. And this is discrete, certainly. There are no decimal values, strictly integer values. So this is a case of discrete uniform distribution. Alright. So now we can obviously calculate the expected value and variance as discussed above. We know the formula, we know the values. Okay. So we know that expectation of x is nothing but n plus 1 by 2. Here our n is 10. So we get 11 by 2, which is nothing but 5.5. And similarly we can calculate the variance, which is nothing but n square minus 1 by 12. And we get it as 99 by 12. Okay, you can further cancel it down and get your values. Now, next part says find the probability. Find the probability that the number on the drawn ping pong ball is between 7 and 10. Okay, so what is the probability that you will pick a ball which is between 7 and 10, which is 8th or 9th ball? Okay, 8th or 9th ball. What is the probability that you will pick that ball? So since we have defined our probability function, we know the probability of picking the 8th ball is nothing but 1 by 10. Probability of picking the 9th ball is nothing but 1 by 10. So the probability comes out to be 0.2. So there is 20, we say that there is 20% chance that you will pick a ball between 7 to 10. Okay, so this is how we know. So this is it for this particular video. If you have any questions, please feel free to ask in the comment section. Thank you for watching.